I'd love to start off by introducing our speaker, Doris. Doris is a PhD student at the School of Information at UC Berkeley, and she's also the creator of LUTS, which is a visual data exploration library. Doris is also recipient of the 2020 Facebook Fellowship in Systems for Machine Learning Award. Before I hand it over to Doris, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console, and we'll be happy to answer them towards the end of the webinar. Also, this webinar is being recorded, and a copy of this webinar will be made available after the presentation is over. Also, Doris has shared some of the material in the tab which you can access to follow along. So without further ado, I'd now like to hand it over to our speaker. Doris, thanks a lot for joining us today.
Thank you, Paul, for the introduction. Hello, everyone. My name is Sorry, I think I might have dropped out or something.
You're back. I think you're back now.
Okay. Sure. Let me reshare my screen. Hold on. Right. Can you guys see my screen right now?
Yes, we can. Yes.
Okay, perfect. So I'm going to rewind a little bit since I don't remember where I left off. So data plays an increasing role in the way that we make sense of the world and for making decisions. And so to discover valuable insights from data, currently a data scientist would go through a multi-step process spanning from data collection and cleaning to modeling and deployment. And in this talk, we'll be primarily focused on the data exploration part of this data science lifecycle. And we'll illustrate how this still remains a challenge for many working data scientists. Now, what exactly is exploratory data analysis, or EDA for short? So the well-known statistician John Tukey describes exploratory data analysis as an attitude and a willingness to look for patterns and trends in the data. And in his book titled Exploratory Data Analysis, he draws this analogy between doing EDA and doing detective work. And he outlines the techniques for doing EDA, and that includes manually browsing and inspecting data, basic querying and computing statistics, as well as visualizations on top of your data. So if we fast forward 50 years from Tukey, what does doing EDA look like in 2021? On one hand, what we have is computational notebooks like Jupyter, which have become kind of the go-to tool for everything from data cleaning, visualization, and machine learning. And notebooks have become increasingly popular for data scientists to iteratively experiment with data through code. And in particular, when working with data inside notebooks, it's very common to use a data frame. And a data frame is a data structure that could be thought of as a table. The data frame consists of columns and rows of data, and you can easily print them out in your notebook to inspect the data that is in your table. And Pandas is a very common Python library that implements a data frame API. It's extremely popular among data scientists, and it contains over 200 convenient functions and APIs to help data scientists load, clean, transform, and analyze their data. So apart from notebooks, we also have interactive visual analytics tools. These include tools like commercial BI tools, such as Tableau and Power BI. And these tools are highly accessible, and they help bring these data insights to the data analyst with the simple ease of a point and click interactive interfaces. However, even with the advent of these incredibly powerful tools, there are still challenges that hinders the flow of data exploration when we go from a question in our heads to discovering meaningful insights from our data. And in particular, we identify 3 resistors that are common to this data exploration process. First, while programming tools are extremely flexible and allows users to perform a diverse set of tasks, they're usually inaccessible to analysts without coding expertise. And on the other hand, while we have interactive tools that are highly usable and effective in creating visualizations and dashboards, these systems are usually very limited in terms of their flexibility, in terms of the tasks they support, and they're very hard to customize. This means that there's a huge disconnect between these 2 sets of tools. And from the user's perspective, having to import and export to and from these tools often presents a barrier to exploration. Our second point of resistance comes from the fact that there's a very high effort that is currently required to visualize your data programmatically. Let's take, for instance, let's say we're given a data set of cars and we want to plot a bar chart of average horsepower by origin. So we first need to think about what this visualization should look like, what graphical encoding we should use, and how do we process this data correctly. And then we need to translate all of these specification details into code. So on the right-hand side here, what we show is 2 examples of just the amount of code that is necessary to generate the single visualization on the left-hand side. And this is based on 2 popular Python visualization libraries, matplotlib on the top and plotly at the bottom. And so the substantial amount of programming effort that is required to generate a single visualization often hinders exploration, especially when the user is at this exploratory phase where they only have a vague idea of what they want to look for. And so note that writing code to plot a single visualization is just one tiny point in this vast space of exploration options. What we usually find is that the analyst has to go through a very tedious process of navigating through a large number of decisions in order to find any relevant insight in their data. And what this means is that when they actually end up with what they're looking for, they can often miss out on important insights that are in their data sets. Another common problem is that the analyst might not know what sets of operation they should perform on their data in order to get to these desirable insights. So they can often lose track of where to search for these insights or get stuck in their analysis. So the 3 resistors that we just discussed represents this gap between the way that people reason and think about the data and what actually needs to be done to the data to get to these insights. To address these pain points, we've developed a lightweight open source Python API called Lux. And the goal of Lux is to make it easier for data scientists to explore their data, even when they might not have a clear idea of what they're looking for. And to show some concrete examples, to help guide users to relevant analysis, Lux recommends a set of visualizations essentially for free to users. As we can see on the left, by printing out any data frame in the notebook, Lux provides an alternative visual way that a data frame can be visualized beyond the typical tables representation. And users can toggle back and forth between these complementary views. Next, to lower the cost of programming, Lux features a powerful intent language that allows users to specify what they're interested in their analysis at a very high level. And data frames can be attached with these intents, which then enriches the data frame with signals about what visualizations we should display to the users that are more relevant to their analysis contexts. And finally, to bridge this gap between code and interactive interfaces, we're bringing the power of interactive visualizations directly into Jupyter notebooks. So that means that the users can visualize their data frame directly into their Jupyter notebooks without having to move in and out of their BI tools or perform data cleaning or modeling separately. So I'm going to show a quick demo of what Lux can do. And if you want, you can follow along our demo by trying out Lux on your own Binder link. So I believe I sent the link on the Zoom chat. Parul, is that correct?
Yes, Travis. It's on the
yes.
chat for the links. Thanks.
Cool. Yeah, so when you click on this link, it will create a live Jupyter notebook with the demo. Note that it can take a couple of minutes for the Jupyter instance to get set up. So I will be walking through the notebook using my screen if you want to follow along. Okay. Can you all see the screen with the Jupyter notebook?
Yes, Travis, it's visible.
Perfect. Yeah. Okay. So in this demo, we'll be using Lux to analyze an employee's attrition data set. So this contains statistics and how the attrition rate, which is the rate that they leave the company. And to enable Lux, all you have to do is add import Lux alongside your pandas import statement. So we're going to import Lux. And then one of the things that we note is that Lux preserves the pandas data frame semantics. This means that any functionalities that you're used to applying in pandas, you can apply using Lux. And so here we're using the same pd.read CSV command in order to load in a CSV data set. And what we can do with Lux is that we can print out a data frame. And what this would show is the tabular view, which is what you would typically see in the pandas when you print out a data frame. And we have this additional toggle button, which allows us to toggle and switch to the Lux view. So right away, we can get kind of an overview of our data set. As you can see, the visualizations that are recommended to us through this Lux view is separated into these 3 different tabs. And each of these tabs are known as an action. So an action is a group of visualizations that are recommended to the user based on some sort of logic. So in this case, what we're looking at is the correlation action. And this correlation action shows us all the bivariate relationships in our data set based on these quantitative attributes. So we have information such as monthly income, we have age, and so on. And note that these visualizations are ranked based on the most highly correlated visualization to the least correlated visualizations, as we could see here. We also show this tab of actions called the distribution action. And the distribution essentially shows us all the univariate distributions that could be generated based on the quantitative data in quantitative columns in our data set. So we have things like the distance from home of these employees, the total number of working years, and so on. And these are shown as histograms. And these histograms are ranked based on histograms that are most highly skewed, as we could see in this case, to ones that are most uniform. So we could see that a lot of these compensation related variables and age are less skewed. We also display univariate distributions of categorical variables. So these are things that that can be plotted as bar charts. So these bar charts show things like, you know, the attrition rate, as well as whether the employees travel frequently or not, which department they're in, and so on. So right away, we can skim through a large number of visualization and start to draw some interesting insights based on what we're shown here. So going back to this view, one of the interesting things that that really quickly captures our eyes is this very triangular looking pattern. And we take a look at this a little bit closer. What we essentially see here is that this is showing age and the total number of working years for an employee. And this is essentially saying that the total number of working years cannot exceed the age, because that is not possible in the data. So both of these kind of checks out with our intuition that it's impossible for the total number of working years to exceed the employee's age, as well as for any employee to stay at this particular company longer than their total working years. So let's say that continuing our analysis, we want to investigate the factors that leads to employee attrition. So beyond these basic recommendations, you can start to specify your analysis interest in Lux. So in Lux, the way that you specify your analysis interest is through this df.intent. Intent is a property, and the intent is specified as a list. So in this case, we are interested in attrition as the variable. So when we enter this in, this is attached to the data frame. And then when we print out the data frame again, what we see is that when we print out the data frame, what we see is that Lux essentially steers the recommendation towards what the user is interested in. In this case, it's the intent, which is attrition. So on the left-hand side here in the current visualization, what we see is that the attrition rate, so there's about 200 employees, about 15% of the employees have left the company, and then the rest have not. And on the right-hand side here, we get another two sets of tabs. One is the enhance action. The enhance action essentially adds an additional variable to the intent that you've specified. So on the left here, we have the number of records, which is then being replaced by the average of some particular measure. For example, the average number of total working years, and the number of years at a company, monthly income, and so on. So for example, what we see here is that for the employees that have not left, they're receiving a higher income, higher average income than the ones who have. And so these are the types of insights that you can start to draw. And we also show additional additions of if we added a categorical variable to this intent. And for the other tab that we're showing, it's the filter tab. The filter tab essentially takes, again, the visualization on the left-hand side and adds an additional filter to this visualization. So essentially what we're looking at is different subpopulations of the data and how that distribution changes. So for example, we can look at employees that work overtime tend to have kind of a higher rate of attrition compared to just the overall. If we look at ones that don't have overtime, it's a little bit lower than usual. We can also look at things like stock option levels, marital status, as well as the job level. So this essentially really quickly skim through how this distribution changes for different subpopulations of your data or different subsets of your data. And to learn a little bit more about how to set intent, you can find a link to the tutorial inside the demo. Lux allows us to specify these intent at a very high level, and the system figures out what are the relevant visualizations to show and ones that are also relevant to your intent. So one of the things that we notice from this tab is that we are looking at the total number of working years and the years at the company. And one of the measures that we're interested in is kind of capturing what is the percentage of the employees' working years have they spent at this particular company. So we're interested in the ratio of the number of years that they spent at this company divided by the total number of working years. So if we do this division, we get this series object. So this is a 1D kind of series object that is typical in pandas. And Lux also shows a visualization based on this 1D series. So when we click on this visualization, what we can see is that the series is visualized as a histogram, as we kind of expected, because this is a ratio, and this numerator would never exceed the denominator, as we could see from the triangular pattern. This number has to fall between 0 and 1, which is shown in the visualization. Another interesting thing that we can learn from this visual view now is that there is a lot of employees that have that fall in this bucket that is very close to 1. This means that there's a large group of employees that have spent almost their entire working life at this particular company. And so these are the types of insights that you can start to get as you're looking at the visual equivalent or visual view of a particular data frame or series that you wouldn't have gotten if you are looking at just these sets of numbers as an array. And so we think that this is a feature that is useful. So we can store this inside a new column, percentage of working year at a company, and create that new column. And this is the exact same syntax, again, as what you would do in pandas. Let's say that we're continuing with our analysis. We're interested in seeing if there's any differences in the percentage of working years for employees that are young versus the employees that are old. And so in order to investigate this hypothesis, we want to create a visualization that shows this relationship between age and the percentage of working years at a company. And Lux allows users to create Viz objects, which are essentially visualization objects of a data frame with an intent. So the way that we can specify these Viz objects is we would specify an intent. This intent is in the same syntax as what we used earlier via the df.intent. And we can attach it, we can essentially also put a data frame as an input here. And so what we can see here is that without having to write the full set of code that is required for a single visualization, we can simply just specify our intent. So we're interested in age and percentage of working years at a company. So when we enter this, Lux generates a visualization that is based on what we're looking for, which is age and percentage of working year at the company. So this is a quick way of, and quick and dirty way of looking at our data. So this visualization is not super informative because there isn't a very strict kind of trend. And so we want to kind of tease apart the age variable a little bit more. So one of the things that we can look at is we can, again, look at the 1D series associated with age. So we can fetch this column age and look at the visualization that is associated with that. We see that the age distribution is somewhat Gaussian, and the average is around 30, 39 or so. So we're going to create a new variable, a binary variable that separates employees that are old versus employees that are young. So here what we're doing is we're saying for employees that are above the average age, we will label this as is old equals to true. And then for employees that are below that age, this variable would be false. So we're essentially binarizing this variable. And so when we print this out, we see that these are the true and false values for each of the employees. And so again, we can very quickly look at the visual views that are associated with these series. And what we can see is that there's more younger employees. So is old is false compared to older employees, but not by a whole lot. So only by about 100 or so. So the difference is not super large. So now that we have this variable is old, we can then start to look at whether young people or old people tend to stay with the company longer. So we can again use this Viz object abstraction and specify our intent. So here our intent is we are interested in looking at the percentage of working year at a company, and this is old variable that we just created. And so when we enter that in, we get the new visualization. And this is kind of interesting because this is actually telling us that for the younger employees, they're actually spending a longer percentage of their working years at the company compared to older employees. So let's say that we're now interested in looking at sort of what are the other columns that are in our data set. So we can fetch this df.columns. This is the typical way that you can look at a list of columns in pandas. And we start to see that there are these variables such as monthly rate, hourly rate, and so on, that contains the word rate, and it has to do with salary information. So we're wondering if salary information matters for whether there's a difference between young employee and old employee in terms of the salaries that they're getting. So we essentially filter these columns to only the columns that contain the word rate in the variable names. So we could see that there's daily rate, hourly rate, and monthly rate. And in order to plot sort of all of these compensation related attributes against the old attribute, we can use this thing called a Viz list. And so a Viz list is just simply a list of visualization objects that we can create. And it can either be specified via this intent, which is similar to what we've seen earlier, or it could be specified via a list of Viz objects. Here we're looking at the example where this is specified as an intent. So the intent here is this list with respect to is old. So we're just going to plot this to see what we end up getting. So what we're actually getting here is the kind of the cross product between the list that we specified and is old. So it's looking at the breakdown of young and old employees for different salary measures. And across all three of these measures, daily rate, hourly rate, and monthly rate, there's actually not too big of a difference between these values. The differences are very small, which tells us that across young and old employees, the salaries are more or less the same. So kind of as a recap, in this sort of section, we kind of saw how the programmatic generation of Viz and Viz List is a very quick and dirty way that we can start to kind of evaluate our hypotheses and ask questions about our data. And so let's say that we go back to the recommended visualizations again. So we print out the data frame again, and we want to understand what are additional things that we can learn from our data frame. So we've already taken a look at total number of working years and years at company. So we're going to, and we also have taken a look at monthly income. One of the things that is kind of interesting that we haven't looked at is this, this variable called distance from home. So this is the distance, this is the how far away the employees are living away from the office. So the distance from home to the office. And this chart is essentially showing that for the employees that have left, they have typically almost 2 more miles away. They're almost 2 miles further away from the ones that have not left the company. So it signals that, you know, distance from home could be an important factor in determining employee attrition rate. So this is a really interesting insight, and we want to either dig into a little bit further or share it with a colleague. So the way that we can do that is we can click on a visualization in Lux, the widget, and we can use this thing called the export button. And so when we click on this export button, what happens is that this visualization gets stored in the exported property of the data frame. So when we do df.exported, what we can see is this at the first item, which actually looks is an object in Lux printed. And to a code that this visualization. So this visualization is generated by Altair. Altair is a Python visualization library. And so we want to print out this code that is associated with this visualization. So we can very easily now kind of copy and paste this visualization into a different cell to exactly reproduce kind of the visualization that we had earlier. The benefit of having this instead of the Viz object now is that we can now do some sort of customization because we have the full code that reproduces this visualization. So for example, we might want to do things like add a particular title, and maybe we want to change the width and the height of the visualization. We could change the color and anything in any of the specification that we can do in Altair. And then we can rerun this visualization and we could see that the style of this visualization has changed. And then we can proceed by saving this and then sharing this PNG file with a colleague. So for more information on how to export a visualization, either to an HTML page or to code, feel free to take a look at this tutorial. So I sort of went through a very quick walkthrough of what are some of the basic features of things that you can do in Lux. So if you are interested, feel free to try out Lux via these instructions. There's also more information on documentation and how you can use Lux through here. So I'm going to go back to my slides. So just to recap, in the demo, we were able to easily kind of load in the data set into Lux and get a very quick overview of the data set by toggling to the Lux view. And we do this while preserving the same data frame semantics in the sense that we would get all the nice functionalities that you would get from pandas, such as importing CSVs, dropping columns, and we can still do all of that inside Lux. And that by printing out the data frame, it surfaced some visualizations that highlighted how there's this triangular pattern in the data, which verified some of our assumptions about what the data should look like. And we're able to compute basic statistics, such as the ratio between the number of working years at a company and the total number of working years. And Lux automatically helped us visualize these 1D series objects. And so by looking at the visualizations, we were able to quickly identify the need for binarizing the age variable. So what we did was we took this age variable and we said that anything below it would be false, anything above it would be old, would be true for this is old variable. And so this was an example of how we could clean and transform our data via a seamless integration with Lux. Via a seamless integration with pandas. In the sense, you don't necessarily need to reload and import and export your data to and from a BI tool. We then learned that, we learned from the recommendations that the average distance from home to work for employees that left were slightly higher than the ones who didn't. So this was an interesting insight that we decided to export from the Lux widget into the code for further editing and sharing. Oops, sorry. And so all throughout this workflow, we had Lux providing these automated assistants to our analysis so that we can explore this data without being boggled down by writing significant amount of code or thinking about how to process the data correctly. And so we saw how a fairly typical data analysis workflow, within this fairly typical data analysis workflow where we're using data frames in a Jupyter notebook, it can be completely transformed by just adding a single import statement, import Lux. So with Lux, working with data frames suddenly now means affording a lot more visual richness to encourage these types of exploration. So Lux is an open source project, like I said earlier, and we've been developing this tool for just over a year now. We've seen a lot of interest from the open source community as well as the data science community. So beyond actively maintaining and developing the code base, we're also looking to work with data scientists who are interested in using this tool and who provide feedback on ways that we can improve Lux. And so we're actively working on these areas. So hopefully, to recap in this talk, we've seen how there are 3 common types of resistors that may hinder data exploration. And we also demonstrated how Lux addresses these pain points by supporting visual data discovery alongside a data frame workflow. We hope that the presentation kind of gave a taste of how Lux can enhance the data exploration experience in the notebook through this very low barrier way of working with visualizations. Like I said, Lux is still undergoing active development, and we would love to work with users who want to try this tool out and who can help us make this tool more useful. So if you want to use Lux on your own for your data science project, please give it a try and let us know how today. I'm also happy to take any question in the remaining time.